Good afternoon, everyone. Good afternoon from Munich, Germany. My name is David. I'm co-founder and CEO of SimScale. I'm based in Munich, Germany. We have two guests with us today from North America. So good morning to North America, or good evening to wherever you're joining us from. Excited for you to join us. Warm welcome to the audience. Before we go into the actual topic, because I have the pleasure of hosting these two gentlemen here today, experts on battery design, battery manufacturing, EV battery design and manufacturing. Before we go into the actual content, two quick logistical notes. Number one, this webinar is recorded, so you're going to get the recording automatically into your inbox. And second, we will be making use of the question functionality of GoToWebinar. So you can, at any point in time during the presentations, just file your questions in the Q&A section of GoToWebinar. We do have a packed agenda today, so we'll see how many questions we can cover at the end of the session, but we will try to cover some of them, and the rest that we don't get answered today, we will be getting back to you following the webinar via email. Having said that, now I'm just on a side role today, because the actual content will be today delivered by our guests today, because the session today is about challenges in EV battery manufacturing. And I'm joined by two experts in this field, Jeremy from EV Tech Insider and then Vincent from ARaymond, who will introduce himself in a second and who will present their expertise in this field in a second. But to set up at the stage of why we put this session together, we at SimScale were only hosting this session today because our mission is helping engineers innovate faster by making simulation truly accessible. And the automotive industry is among the industries that is adopting the SimScale and cloud native simulation the fastest. One of the drivers of it is that obviously all of the automotive engineering teams are in a situation where the powertrain is changing rapidly to, towards EVs, FCEVs, and all of them face the pressure of certifying new components very, very quickly. It's a very open, there's still like massive architectural choices being made about all of those components, massive engineering, design choices to be made. And so all of these automotive engineering teams are looking for ways to design faster, engineer faster, find a solution that works faster, get to a good design faster. And that's sort of how we get in touch with many of those engineering teams. We talk on a daily basis with those teams, help on many different components. And this is also how we got to know Jeremy and Vincent. Jeremy, covering the EV technology space as a publisher since a while, doing a lot of research. Specifically today, he'll share a lot about the research he's doing around cell manufacturing. Vincent, having decades of experience in connector design, will speak about the work he's doing. He and his team is doing at ARaymond about high voltage battery connectors, cell to cell, module to module. And so both of them have very interesting points of view, very interesting expertise gathered over years and working in the EV industry. And so we wanted to host these experts today, bring them together, have them share their expertise with the community here in SimScale. And hopefully everybody in the audience today is likely, from the guest list we can see, is in some shape or form involved in engineering EV components, specifically around the battery, from a cell to the module to the pack. And so hopefully everybody today over the next 40 minutes or so gets some good information, some good insights, some first-hand best practices, maybe some new ideas for their engineering work. And that's what we call sort of the Engineering Leader Series, where we try to share knowledge, inspiration for your engineering work, for your engineering team. Having said that, Jeremy, would you mind quickly introducing yourself right now to the audience?
Yeah, absolutely. So my name is Jeremy Ewald. I've spent my entire career in EV engineering media. About 8 or 9 years, I've covered one thing, and that's the manufacturing and design of batteries, power electronics, motors, and charging stations for EVs. I run my own publication. It's called EV Tech Insider. And we cover just that, and excited to talk about some of my research on how AI is changing the battery production, especially here in the West.
And we're excited to have you, Jeremy. Thank you so much. We'll get into that in a second. Vincent, would you mind just continuing introducing yourself?
Yes. Okay. So I'm Vincent Lin. So I have been working in the connector industry, electrical connector industry for more than 25 years. I'm hoping today's webinar can provide some of my experience for your reference, either design a high power connector in the future, or for the customer, from the customer point of view, how you're going to select the high power connector for your application will be covered in today's webinar. And hopefully this will give you some insight and how we benefit from the SimScale when we have such a short period of development time and in order to develop the product and proving and testing and meeting the simulation result. And so that will be covered in today's webinar. Hopefully that will be helpful.
Excited to have you, Vincent. Awesome. And we
Thank
thought
you.
about the best way to structure the content today is Jeremy's research is mostly on today at least focusing on the cell level. So we're going to start with the cell level, and we're going to go over connectors, cell to cell, module to module to Vincent. So let's start with Jeremy's presentation around his research first. Jeremy, would you mind taking the baton and sharing your presentation?
Absolutely. Show my screen here. Can you see my presentation? All good?
Yes, that works.
Okay, cool. I'm gonna set a timer so I don't yap everybody's ears off. Cool. So again, my name is Jeremy. I run a publication called EV Tech Insider. We cover the manufacturing and design of batteries, motors, power electronics, and charging stations. But that's not really a niche anymore. That's kind of become just automotive manufacturing. So we're actually looking at niching down a little bit further. The first thing we're doing is EV battery manufacturing. So we just started a simple newsletter on just that, and I'll talk more about that at the end. But my presentation is from materials to manufacturing, how artificial intelligence is redefining battery production. On the agenda today, first I'm going to start off with a quick roundup of the US battery market, some quick definitions, and then how a bunch of companies, I'm just going to showcase what they're doing, how they're applying AI to make better batteries. So the first thing I'm going to show you is a roundup. So we have these are all the EV battery plants either producing cells or coming in the US, and I will link to the TechCrunch article. You can read that yourself. So we have what's been deemed the battery belt that runs from Michigan down to Georgia. So lots of new plants just popping up, and most notably we've got BMW, their Spartanburg plant, supposed to start producing cells in 2026. Daimler, Packard, Accelera, and Eve Energy. Accelera is Cummins, the diesel powertrain manufacturer. It's their battery business unit for heavy-duty batteries. We've got the Blue Oval Parks by Ford and SK On. They've got 3 plants. 2 of those should be starting next year. And then we've got the Ultium Cells plants. Those are partnerships with GM and LG and GM and Samsung. Actually, I live like 20 minutes away from the GM and Samsung plant. It's in New Carlisle, Indiana. So a couple days ago, I just popped down the highway and took a picture of it. And that's where they're at. So they say by 2027, they're going to produce cells. What's interesting just in general about this is, this whole region was the biggest employers of our regions, and the biggest employer of my city of South Bend, Indiana, was Studebaker. And this whole region was all automotive. Everybody worked for some sort of automotive company. And we all know the story of what happened with that. It decimated this region. And for a long time, decades, everyone lost their jobs, and the economy has been pretty rough. But now we're seeing like multi-billion-dollar investments coming back to these places and thousands of jobs. And yeah, we'll see. We'll see where this conversation goes in the next 2 years when these people start producing cells. And I think AI is going to help them achieve that. As a whole, the battery industry worldwide is growing at about 16.1% every year. And if you didn't see, about 2-3 weeks ago, the Department of Energy just announced $3 billion in funding for battery companies in the U.S. And that wasn't for just cell manufacturers. That was everything from lithium extraction, processing, recycling, and design, and cell manufacturers themselves. So we'll see where that goes. We've got several interviews planned with those companies to find out just what they're going to do with that funding soon. For some really broad definitions, and I'm not an AI expert, but here's the general idea of that. So artificial intelligence is kind of like a broad definition of giving machines intelligence similar to humans. So a machine that can solve problems, think creatively, make decisions, things like that. That's kind of that broad scope. Machine learning is a subset of that, where you give that machine algorithms and data. It makes decisions based on that and learns from those outcomes. It gets better and better. And then deep learning is a subset of that, which is similar to machine learning, but it uses neural networks, which is very similar to the way that humans think. If input, context, connections, and then outputs, and it kind of learns from that. So really, really broad stuff. And here are the companies we're going to go through. So materials research, cell and pack design, manufacturing inspection, and validation. I've got huge companies and tiny little shops. First off, Microsoft. So they just announced this, I want to say about 2-3 months ago. And the takeaway is weeks, not years. So they partnered with PNNL. They use the Azure Quantum Elements tool. And the gist of it is that they took 32 million potential solid state electrolyte compounds. They put them into a big database with an AI model, and they filtered through those to find the best potential candidate. They had that AI run experiments on that on those materials and make predictions and suggestions on what's the best compound. So they took 32 million potentials, whittled that down to about 500,000 stable compounds, and that only took like 8 hours. I think it was less than 10 hours to get that done. Then they ran more and more tests. They eventually landed on one electrolyte that was a blend of sodium, lithium, yttrium, and chloride ions. And they say it can reduce the lithium content by about 70%, which is huge. And what's really interesting, again, the takeaway is weeks, not years. There was an NREL engineer who commented on this. He said, basically, this would have taken us 20 years, and they got this done in 80 hours. So this time next year, we'll be interested to see where material science is and what problems are we even working on that are just delayed by manpower and tedious work. So really interesting stuff. I've got a link to the article if you want to see how they did it down below. Next company is Citrine Informatics. And so what they do is a no-code AI-driven research assistant. Basically, it's an AI model for researching materials that runs tests and makes suggestions. And you don't need to be an AI expert to get this done. So you load this model up, you kind of fine tune it with your own IP. So all of your historical test data from the lab goes into this model. And then you can ask it questions, make tweaks, and I just interviewed them and got a quick demo on it. It looks pretty intuitive, and there's all kinds of knobs and little levers and changes that you can make to the formula to have it run experiments. For instance, let's say like, this material in the market just started to have a shortage, and now it's very expensive. So how do we make this happen with these compounds and what we have with 30% less of this material? Make a bunch of suggestions, tell us what we should put in that lab to get those real world results and get hopefully some good batteries out of it. And that's the power of Citrine Informatics. So this is being used by several companies, Panasonic, Scion Power, lots of chemical manufacturers, and they offer data services to help you fine tune those models and kind of get all those into one single data silo from all of your test data that you can use to build better batteries. They've got a cool guide on how that model works. You could download it here. SES AI. This is a lithium battery manufacturer, lithium metal battery manufacturer for EVs and eVTOLs. They just announced this a couple of weeks ago. They're partnering with NVIDIA and some AI servers and cloud services. It's a little bit in teaser mode, but they say what they did was they loaded up NVIDIA's supercomputer with over 1 trillion potential compounds. And then they're building a large language model on top of that using Llama 3, which is Meta, Facebook's ChatGPT competitor. It's open source. They're basically combining those two and creating their own research assistant where they can ask that supercomputer, whatever sort of research questions that they need. And this was just announced, so we'll see where this goes probably in the next 6 months or so. But they're gonna make some finalists and then begin testing those at their foundry in Massachusetts. So excited to watch this one. Article link for that one as well. AIonics, you may have heard of these guys. It's the info is a little bit sparse. They're kind of in early access mode. They're a generative AI startup, and they say they're using AI-accelerated quantum mechanical simulations and physics-based simulations to run experiments on billions of molecules. So essentially what they've also done is make a research assistant and built their own large language model. You can see there's a little bit of a trend here. They call theirs ElectroBot, and it's trained on all the battery literature, textbooks, research, and test data. And the researchers, the battery scientists, can ask it questions and have it make suggestions. They're working with Cellforce, which is Porsche's battery subsidiary, Form Energy here in the US, and Qberg, and they are in early access mode. I think you can get access on their website. Onto the design side. So LG Energy Solution, they just started teasing this a couple months ago, and I'm really excited for this one. So they call it the AI model to optimize cell design process. And I imagine they'll get a more catchy name once this, once they have more info that comes out, once this kind of hits the market. But what they did was they took 100,000 cell designs, put that into an AI model, and that will help the design engineers at LG determine the optimal cell design for customers. So here's how it works. A customer says, we need cell designs that look like this and fit these parameters, fit these properties. Can you make it for us? LG Energy Solution, their design engineers sit down for 2 weeks. They iterate, validate, and then after 2 weeks, they say, here's the design, here's what we think you should do. And the customer says, okay. Instead, the AI model does that. So instead of that 2-week design process, they have an AI model they say is going to do that for them and condense that into 1 day. And really interested to see where this goes. Again, it's more on the teaser mode, but they say they're going to have more info on this in October of this year. We've got an article link down below as well. Onto pack design. I just found this the other day. I figured I'd throw it in there just for some variation. So Voltaplex is a battery pack manufacturer. They developed this internal tool called Voltex.ai. Essentially, like customer will come to them and say, we need a cell that does all these things and it meets these requirements. And they had this internal tool to make it faster for their engineers. And they figured, why don't we just open this up to the internet and let anybody use this thing? And that's exactly what they did. So Voltex.ai, it's a free tool. It doesn't look super comprehensive. It looks pretty simple, but nonetheless, I thought it was interesting, and it's in alpha mode right now. You can pick like the different insulation layers, epoxy materials, cell models, and casings, and all this stuff, and it will pop out what it thinks is the best design for you. So Voltex.ai. Cognex. So this is a machine vision system manufacturer. And they've machine vision and AI and all this is not new for manufacturing, especially not battery manufacturing. But Cognex, they've taken it a few steps deeper. So they really, what they do is they help you harness the power of deep learning to catch battery defects in your battery line and predict those before they happen. So deep learning to set up these neural networks is apparently a pretty big task, but they have the experts who will come to your line and help you set those up and make things more efficient and more effective. And the beauty of deep learning is that it can think like a human can with a lot of context. So, you know, for instance, on a battery lineup, if there's like a smudge on the shell of a prismatic battery, if there's a little smudge on the outside, that might not be that big of a deal. But if there's a smudge on the electrode sheet, I mean, that's like a functional defect, and that would definitely not be okay. And humans can distinguish that, and so can deep learning. And there's all kinds of little variability like that within battery lineup that they help you set up and detect and all this stuff. You could download the guide on how they apply deep learning to battery manufacturing here. It's pretty interesting. Honeywell Process Solutions. So we all know Honeywell, this is their manufacturing and process division. So they have the MXP platform. It's called Manufacturing Excellence Platform, which is not new. It's used by several industries. It's just been adapted to battery gigafactories in the last 3 or 4 years. And essentially what this is just a one easy to use display of all the process data for that entire product from raw material all the way down to end product. It's a way to put all these different data silos and departments and put all their process data into one piece of software that when something goes wrong down the line, that division can go upstream and say, oh, okay, like what happened with this batch of slurry on this day? And they can immediately check out all the factors and parameters and figure out what went wrong and hopefully prevent that from happening again. So that's not new, but in the last few months, they just announced they're integrating AI and machine learning into that. And I think this is basically, it's ripe for that because it's just a computer using data. And AI can just do, as we see the theme, way faster and way more effective, way more efficient than humans can. So they just started integrating AI in that. The details are a little sparse, but they say it could potentially reduce material scrap rates by 60%. So I've got an article for more info. And the last company is Monolith AI. So this was developed by a rocket scientist at NASA. His name is Richard Alfeld, who was validating rocket designs. And when you add anything to a rocket, like there's just so much testing. We all know how aerospace works. You only get one shot. So when you add anything to a rocket, it cannot mess up. It is just weeks and weeks and weeks of testing, and that is expensive and tedious and probably pretty boring. So Richard developed a machine learning model that helps not only run those tests, but also suggest what they should even be testing for this new component. So what things should we even be looking out for? They use machine learning and AI to develop all that, predict all that. And the first thing it did was like, hey, this could be used for battery validation. And that's what they're doing. It's being used by Webasto, BMW, McLaren, Honda, About Energy, and many others. And they say it can decrease the battery testing time by 50 to 80%. And we interviewed them a few months ago, article down below, and we have a webinar coming up with their team in October when they will do a quick demo of the AI model. So pretty fascinating stuff. And that's all I've got for you. So the overall theme is just like, weeks, not years, or you could say gas on the fire. No one knows where this is going, and we are starting to see, 20, 30 years be pushed out in a couple weeks. And I will be really interested to, put a stake in the ground and 1 year from now come back and go, oh my God, remember when we were talking about that stuff? And see where we are as far as these battery manufacturing plants and what problems that we have in the battery industry. So it's pretty fascinating. Again, we do we just started a really simple newsletter on just manufacturing EV batteries, cover stuff just like what we talked about and all the interviews from these companies and webinars and downloads and articles and stuff. That will be on evbatterymanufacturing.com. We are looking for new content. So if you have anything interesting, webinars, white papers, content, interviews, anything, just let me know. Shoot me an email at jeremy@evtechinsider. And otherwise, thank you for your time and attention.
Thank you so much, Jeremy. That was a whirlwind through AI, ML, and battery manufacturing. Jeremy, if you don't mind, one or two follow-up questions, specifically on the aspect you covered about the AI discovering materials in the beginning of the presentation. I understood this is just ongoing research, or are we already seeing those AI discovered materials going into production?
Well, we'll see. So, I mean, anybody can make a really interesting, stable, what looks to be a great, compound for a battery in a lab. And then even start off with small little like coin cells and maybe some small pouch cells. But commercializing batteries is a whole different ball game, which is, it's one of the reasons why Tesla doesn't really make their own batteries and they partner to get that done, because that's a whole different thing that's really, really difficult. So we'll see. But again, the overall theme is like these problems that we have today, as we've seen with the Cognex and other companies that apply AI and ML to manufacturing, and they solve those issues of commercializing these new battery chemistries. But we don't know. I don't know. Typically it might take 5-10 years to get that to commercialize, but maybe that gets shortened to a year or something. So be excited to see where that goes.
For sure, some disruption going on there. And then like all the different use cases of AI that you've mentioned, again, I think you're seeing so many different companies, so many different teams, so many different organizations. Do you see any sort of broader trends or sort of, a segmentation of trends, AI trends going on in EV battery manufacturing?
Yeah, I mean, a lot of these companies, especially in materials research, they are all seemingly making AI models loaded up with gigantic database with with all of the data that we have on batteries and materials and the tests on all of that, and loading it in way more than any human could hold into your own brain, and then making building their own large language models on top of that for humans to be able to access that information. Instead of ones and zeros, they can split it back in English or whatever language that you speak. So that seems to be a pretty clear trend. Yeah, I don't know yet. We're also seeing machine vision. Like I said, that's not new at all, especially for manufacturing, but that's being more widely adopted by almost every single company manufacturing batteries. And yeah, as far as trends, that's again, we don't know, but those are the things that we're seeing. Everybody else is tying AI to their product in some way or another, and sometimes just marketing, sometimes it's a huge breakthrough.
Fascinating, Jeremy. I guess like we're all experiencing this situation. It's hard to stay abreast, or just to stay up to date with all the news and all the technology that's being done. And Jeremy, I'm not sure if your presentation helped because like now at least I learned like a bunch of new things that makes it even harder to stay on top of that field. But much appreciated, Jeremy. Like, and the type of research you're doing, what you're sharing with the community. Thank you so much. Now, coming from materials, cell level manufacturing, sort of, I guess, like up the battery stack, connecting cell to cell, module to module. Vincent, you've been doing, you and your team at ARaymond has been doing fascinating work around higher level sort of connectors in battery, cell to cell, module to module. And you've been kind enough, sort of, share some of the work you're doing, and then of course, because you've been working now with SimScale for a while, of course, sharing some of your experiences there and sort of how you're incorporating simulation into this design work. So we're very curious to hear, some of you sharing some of your expertise, some of the work you've been doing in this space. So Vincent, over to you.
Okay. So after we learned a lot from Germany and on the EV Tech Insider, let's bring it to the smaller scale. He is giving us a big broad picture for all of the cell, how to make all of the cell, how to make all of the battery pack, right? And I'm providing a solution for you to connect them together to make it better. So maybe let's take a look at the next slide. Okay, so I'm Vincent Lin. So if you look at the slide here, you will see I have been in the connector industry for maybe more than 25 years. I'm lucky enough to join several industry, represent the company, join several industry connector standard, starting from USBIF, which is like 2,000 years ago. So USBIF developed a USB connector and joined the DisplayPort committee, development DisplayPort connector. I actually wrote the DisplayPort connector, created the DisplayPort connector as an industry standard, and joined the OCP, which is data center environment, and joined the US car committee to create the US car 48 volt mild hybrid standard. All of these standard for the electrical connector has been many years. What I see is the reason I move into the automotive industry is we all know the PC industry is almost gone now, right? I believe your next car will be your next PC. The automotive industry will be next PC industry. We are seeing all of the connector content into your car, either infotainment system, mobility, or connected. And right now we are focusing on the electrified powertrain, which is the area I really enjoy to work on that. It's been 10 years. I focus on all high power connector run. So I believe for the EV adoption, right now we are seeing the problem of the EV industry is the cost, right? Everyone's trying to reduce cost. High power connector industry is a brand new area. From all of the connector standard I've been very familiar with and about the connector standard and the testing, all of the standard actually still based on the 30 amp maximum current, 30 amp per circuit in the PCB environment with a natural convection test requirement. But we are seeing all of the customer, either the data center or EV or electrified powertrain, they require 300 amp per circuit with a certain thermal solution. So the connector industry, the standard is not really catch up to the current situation. In the 10 years ago, no one was thinking about you are running more than 30 amp per circuit in your PCB or in your system, right? But we are seeing 300 amp right now. So this industry has and also the problem right now is all of the car manufacturer OEM is doing the design differently. So it's hard to like connector industry or PC industry to create a standard connector. And with this type of high power connector, you will see all of the connectors company providing the connector is going to be very, very expensive. So nowadays, everyone just terminate the battery by the traditional boil it down or weld it. And without reliable connector, it's hard to reduce your manufacturing cost and efficiency. We see that in the PC industry. With a reliable connector, really can reduce your assembly cost and give you a reliable and give you a more efficient in the assembly cycle time. So today I'm going to talk about some of the things we learned on the connector industry, how we're going to help you guys to reduce your cost, how we're going to develop your product for the high power connector from the experience I have. And I have been doing like a high power connector for more than 10 years. And my majority career is in Molex for about 20 years. And after leaving the Molex, I actually went to several different major connector companies and developed an EV connector, high power connector, and developed different technology for different companies. And so I think that this is all of this experience I have because of roles. I have been using several different software to develop a high power connector. With that, I can provide some of my experience on how you select your simulation software, how we benefit from the SimScale when we develop a high power connector. Okay, so let's take a look at the next slide. Okay, currently I work for ARaymond company. A company is 157 years, a global company. In ARaymond, we are partner with all of the OEM and automotive customer to create a better assembly efficiency product. And so you will see we have, since 2017, we have a lot of offer for the EV battery market or EV industry. We have the high power, high voltage routing, and we have a cable and a tube fastener, and we have a panel and a trim clip, and we also have a cleaning system and to help your sensor and cleaning your radar. And we also have a quick connector. Our quick connector can integrate the pressure sensor and temperature sensor. All of these is great offer for your EV adoption. And of course, myself is working on the high power connector portion of the business. And we usually partner with our customer to simplify your system architecture to achieve your assembly efficiency, safety, and as a European company, our headquarters is in France. We also focus on the sustainable solution to try to meet the 2030 net zero goal. So take a look at the next slide here. So as I said, ARaymond Mobility Group, we have an EV battery connector solution, which cover most of the battery pack trend right now. We know the current battery trend is either you do the module architecture, or you do the cell to cell, or cell to the body, or cell to the pack solution. And for those, for the module architecture, we have a flex MTM, which is building the flexible bus bar inside without welding. And we also have a cell to cell connector to connect your cell without welding. So our connector actually providing you a long-term stable performance and a low-cost quick connect and complete solution without welding. And the most important thing here is it's a lightweight. compare your traditional bolt down electric, the way is lighter, but provide the same performance or even better. And we provide the high speed power delivery. In some of the design, we can include in the short circuit protection. And in all of the solution is sustainable and recyclable, and provide you a serviceability. So as a connector, as a customer, when you select your connector, so you want to look at the low contact resistance, which will reduce your thermal solution, right? They also will reduce your weight. And also you want to look at the long-term contact performance stability, which we test and provide you proving the long-term stability. And with the latest battery pack testing requirement, they all need to run the short circuit current short circuit test. With a short circuit test, it will create a huge current and in a very, very short time. We found out from our simulation or our testing, our design will helping you on the short circuit environment when there's a short circuit happen. So next slide, please. Okay. So we develop our high power connector, or when we develop our high power connector, we all need to run all of these simulation and all of the tests here. All of these tests can be done by the SimScale. And so we, like say, we did the structural analysis to find out maximum stress and the insertion force and contact force. And we also tested to prove it matching to the SimScale, correlate with the SimScale result. Geoheating analysis to give you the electrical potential and current density. We also run the thermal analysis. We prefer to run the thermal analysis under the CFD environment with a geoheating situation. They give you a temperature rise and thermal budget for the customer. Like I said, for the latest short circuit test, you need to run the short circuit test in the battery pack. We found out the short circuit test will induce a huge current in really short time, sometimes like 15 kilo, 15,000 amp in millisecond situation. That create huge magnetic force, which will impact your joint, either you bolt down or weld it or using a connector. We will be able to use in the SimScale electromagnetic analysis to our connector analysis. And we know the SimScale has some future development, which will match into our future roadmap when we try to develop our future product. So all of these testing has been done and simulation has been done in the SimScale, and all of the simulation we can use in one SimScale subscription to do all of those. And the best part here is all of the simulation job is submit to the cloud-based cloud computing. So that will freeze up our laptop, let us focus on our design without, the computer can work on the design and the SimScale cloud computing can work on all of the simulation in the same time, which will really reduce our development time and design time. And now we have the simulation result and correlate with our test result. Now we have a database, and that will make the whole development time even shorter. We can easily to scale up or scale down the connector due to the different customer requirement. And so that will really reduce our product development time. Okay. Next slide, please. Okay. So then let me talk about some experience I have on the software, simulation software, because like I said, I have been several different companies using different software, and why we select the SimScale. And traditional CAE system set up in most of company, you will have, because the CAE software is difficult to use, and if you are not using it all the time, so usually the company will set up a CAE expert and to do all of the CAE for everyone. Now everyone need to submit a CAE job to one or two people, and their workload become an issue, right? So it could become a bottleneck of a whole company's project development, right? Because every project is going to only one person. And we know, like in the connector world, you need to find a perfect optimized design for that connector bin, sometimes requires several simulations. So when you have a design change, then you need to communicate back to the CAE expert to run the other time another simulation. And actually, the designer or project engineer is close to the customer. They are understanding the design requirement the most, right? But they need to communicate that back to the CAE expert. So back and forward, they will take a longer development time. And we found out actually if engineer can run some CAE work, even some basic simulation, that will help them design the concept design more feasible and according to the physics, right? And also based on their simulation, running the simulation, sometimes some creativity will come out from there. They will hugely reduce your project lead time, right? But in order to let every engineer to run the simulation, now you need to install the software to each laptop. Software installation and upgrade the software and hardware requirement, all of these are going to be very expensive. So sometimes in order to collaborate with a global team, you need to transfer the file from the one location to the other location. CAE file usually is huge file. So data sharing, transfer the file, or you need to set up the solver to solve all of the CAE job for the global company. It's going to be very expensive, difficult. With some country has a firewall issue, then there's another limitation there. That will create a lot of resource and problem, expensive there. So on the software side, these are just from my past experience. Maybe some of software has been updated. So like say, I did the HyperMesh and the Epic solver before. So it's pretty good software, but the mesh is going to be difficult. You can see on the right-hand side that picture. Usually in the connector world, we like to use in the cantilever bin analysis. We'll prefer using a break element. So sometimes like this complicated geometry in the previous application we are doing, software we are doing, it might take like half day or 1 day to to meet all of the good mesh quality. That's why a lot of companies actually outsourcing their simulation software to a different location. And so when there's a design change in this setup, HyperMesh plus Epic solver, you need to probably redo all of your setup, boundary condition setup, everything. And also there's not true CFD and user interface is difficult to pick up the command. In the AutoCAD CFD situation, we did that before. So it's pretty good CFD software, but it's not a lot of mesh control. And when there's a design change, and it's going to be difficult, and accuracy of the thermal analysis is another issue. NX simulation is good to link to the model. When you have a model change, it will change in your simulation, but there's no geoheating, there's no CFD. If I try to do the same thing like I did in previous slide, all raw simulation by using an N6, I need a lot of module to do that. It's going to be very expensive. And the other thing is there's no true CFD plus including the geoheating in the N6. So with all of the above, you will see it's a huge IT resource and manpower, and especially for a global company, try to coordinate all of the different country, collaboration with all different country design centers is going to be expensive and difficult. So that's why we select SimScale, which is a cloud-based simulation, and you got all of the module in one subscription, and it's quick and easy. There's a quick and easy mesh tool. If you look at the right hand side that picture there, in the SimScale, I can just pick some of the outside or inside surface. The system will automatically create that mesh for me, and it's a CFD and plus a geoheating, which is great for our power connector simulation. Right now, they are including a magnetic analysis. Like I say, in the high power connector industry, this is going to be very helpful. And there's more to come in. And next slide, please. Okay. So as ARaymond, we usually will join the battery show. This year, we also going to the battery show. You can come to our booth and take a look at all of the product all of the offer we have, and welcome to join us in the battery show. That's it. Thank you. Hopefully I gave you guys enough time.
So thank you so much. Very, very interesting for sure. Vincent, one or two questions from my side directly to this. Could you, because a lot of the patterns we're seeing from automotive suppliers is the fact that every requirement from every customer is a bit different, right? While, of course, there's a repeating pattern, sort of you don't need to start from scratch. It's like the design space is different, maybe the specs are a bit different. Each time there's a bit of a difference. Now, it seems like the connector is a very small component, but how easy or hard is it to create a new battery connector for a different customer requirement? Can you talk a bit about that process?
Yes. So, like you say, like you look at the picture here, you see there's a module-to-module connection, there's a cell-to-cell connector, right? The problem of the EV adoption right now is every customer doing differently, like you say, and they are not communicating each other. They are not even sharing their information to outside. So it's hard to, like a PC industry, to standardize a connector for everyone, even the standardized test environment. Like I said, the test environment right now is still under 30 amp per circuit. Now it's more than that. But what we did here, by using a SimScale, all of the simulation software we can use, and we develop our connector. Now we have a proven test result to correlate our simulation. So now it's easily like a very easy, different customer, if the module is bigger or smaller, the tab is bigger or smaller, the requirement is different, we can easily to scale up or scale down with that proven test result, and SimScale will provide us the simulation result, which will match to our test result. So it's become really easy to our development. So if we are using the NF, I even can write an expression and just type into how much current they require, what is the distance, then the system will build out the design for ourselves. It's become very, very easy now.
That's the future Jeremy painted earlier, right? Some more AI for that process. Yes. Nice. And so you like in the preparation for this call, you shared that sort of there's at times issues with the current battery termination. Like what kind of issues do you see these days for the current battery termination? What's the challenge there?
Yes, just like I say, because there's no standard. So everyone doing design differently. There's no one OEM or several OEM come in and say, let's define a standard connector for a battery pack, right? Everyone doing differently, the size of the battery pack differently. And so it's gonna be very difficult to create a standard, right? So then there will be a problem. And that's why most of the company right now, instead of doing like a PC industry have a standard connector or using a connector, the automotive industry more using the traditional way to do, just using a screw to bolt it down. But we know the problem of the screw is when you screw it down, there's a long-term reliability risk, which you won't be able to see it by your testing without all of the understanding, right? There's a vibration issue. There's a thermal expansion issue. Some of them using aluminum to connect to the copper, which is different CTE thermal expansion coefficient. And all of those will create a different CTE mismatch. Vibration also, the long term, you're gonna see that joint resistance, the clamp rod will lose. Then that will cause a long-term stability problem. And that's actually is a huge risk for all of the battery. Maybe that's why we are seeing all of the battery pack is burning down. Sometimes it's not because of your cell, it's because of connection. And connection usually is a huge bottleneck for overall resistant area. And the other way they can do is just weld it down, right? Weld down, it get you really, if you weld well, give you really low resistance. However, the thermal expansion, vibration, that will affect your joint integrity. For long term, it's still a risk. And it's not easy to repair serviceable. We should look at the traditional PC industry, how we develop a connector, and using that to help in the EV industry to moving forward, the EV adoption, everything. So that's why we are here, try to promote the connector here, and hopefully that will help reduce the cost, help in the assembly efficiency. Yes.
Nice, Vincent. But I think it's a telling tale that it's such a clear signal that the architecture of those powertrains is not as mature yet, right? So there's still like more exploration, like many issues are still to be uncovered as those vehicles are longer in service. So it's fascinating. On the one side, very challenging. On the other side, very fascinating, and leaving a lot of open space for engineering innovation for sure. We have a couple of minutes left, so maybe we can get through 2 to 3 questions for both of you before we wrap it up. Jeremy, one question around sort of, I guess, the old, so the question around how AI is going to impact the job market in this space. So, you know, like any thoughts from your end on the different AI examples you've shown on whether or not AI will be net positive or net negative on the job market, and specifically when it comes to battery manufacturing?
Yeah, as a whole, again, it just depends. It's all purely speculation at this point. But if you think back in time, there was a time where we had accountants and construction people would use what's known as a calculator to calculate different equations. And then one day the Excel sheet came out, and you click the bottom right corner of that cell, and it's going to do 10,000 of those calculations in less than a minute. And that would have taken you days and days and days to punch in a calculator and write that down or do long division or whatever. And that's kind of the same theme that we're seeing with AI too. So I think what will happen is AI probably won't come in and take your job from you, but engineers who do use AI will do 20 times the output. They will do what's equivalent to an entire department of people doing what you do. And they'll do that, by themselves. And again, we're just gonna accelerate this, just gas on the fire. And those who adopt these, and you don't have to become an AI model expert. You don't have to go and learn quantum mechanics and learn to code and all these things. I mean, the basics would be great to know, but it's just a matter of learning to use some of these no-code platforms and understanding what neural networks are and how they can be applied and how they can make you better. Because again, if you don't kind of learn how to use these new tools, the other engineers and other people will, and that is the risk, is not adapting to this.
Yeah. Vincent, you wanted to say? Of course.
Yeah, if I can add something there. So in Taiwan, we are talking about, when we are talking about AI, there's 2 different definitions. If it's artificial intelligence, you give all of your decision right to the computer, to the system, then there might be an issue, right? And we all talk about that in the autonomous driving situation. But if we are talking about AI as an artificial in-system, then there will be a different story. I think what we should move forward is artificial in-system. So like Jeremy talked about, you are using all of the tools to help you on your design and help you making a decision. It's not giving all of your decision right to a system. So that will be something, I think there will be more variable in the future.
Nice.
Yeah.
Very nice.
I think that's right.
Yeah, I agree. And then probably time for one last question. And I assume it comes from Vincent, because you're supplying the connector, and sort of you've done a lot of thermal analysis on the connector part and thermal management. And now, if if customers of yours or engineering teams working with you work in the overall pack design, the whole battery pack design, any guidance or any awareness, any hints you're having for those engineers that are working on the full thermal battery pack simulation? Do you have any, what should they be aware of? Any hints, any best practices from you?
Yes, so from the high power connector industry, when we look at the high power connector industry, the most of the problem is the bottleneck of your resistance is your contact resistance on that contact surface. And we have been seeing several simulation software, which is a simulation work done, which not consider the contact interface resistance. So when you are working with a connector company or when you are designing your thermal analysis, either unless you are welding down the joint like the picture showing here, if you have any mechanical joint or using the connector, you want to get your contact resistance information from the connector supplier. However, you need to be aware when they provide the contact resistance number to you, that's in the room temperature. We need to be aware the material itself has a temperature coefficient. So they will need to give you the not just the room temperature contact resistance, they also need to give you the, depending on temperature, different temperature resistance will be increased. So they need to be aware of that. And the most important is select the right connector company. If some of the connector in the room temperature is good, but over time there will be resistance will be increased, just like your boil down solution, and that will cause the problem. Your thermal solution, your thermal system will need to handle something unexpected, high temperature there, so that might cause in the thermal runaway or thermal event. So that's important to know that. Okay.
Yeah, very nice, Vincent. Thank you so much. And I assume, because we're running short on time, but Jeremy, Vincent, I assume it's okay because again, like, the body of knowledge you have, the experience you have in your field of expertise, like you showing up here shows that you're willing to share this with the community. I hope it's fine to offer to, the audience, whoever will watch this recording later, that they could reach out to you, sort of get in contact. I know you guys are giving back to the community, like building, I guess, like the future of EVs together. So to everybody in the audience, feel free to reach out to these experts. And with that, I guess, like, the last thing to say is we will continue to sort of, innovate in this field. We have innovators here, so we're excited about what the future holds. And I guess with that, we're closing the session today. A big thank you to the audience for following us. I hope you get some good information and tidbits out of this. And I'll see you hopefully in the next Engineering Leader webinar series. With that, thank you so much for the presenters. Good.
Thanks,
thank you so much.
Okay, bye-bye.
Bye-bye.